Hello everyone. In this video we're going to be discussing how to lead the player around the level by using glowing or flashing items. You've probably seen this in a lot of videos to where when you're supposed to interact with something in the level, it might be glowing a different color, flashing a different color, flickering a different color, or it might just have a completely different texture on it altogether. So to do this, we're going to use something inside of a UDK package that already exists as an example, and then I'm going to show you how to set up the kismet. First off, if you go to your content browser in UDK and you go to the package titled top-down test, you can search for the word key and you will find a flashing key. It's a 3D model of a key that flashes. If you double click on the material, you will open it up and you will see that there's a cube that flashes orange. And you'll see that in the material to the right, it shows you how they have set it up so that it flashes. Now the easiest way is to just highlight all of those by holding Control and Alternate and dragging a red box around it, and then Control C to copy, and then Control V to paste it into your material that you've created for your object. However, we're going to walk you through that so that you can understand why it's working and how it's working, so that you can use it in other ways other than just copy pasting. So the first thing you want to do is you want to add your static mesh into the level as an interp actor. That way we can use it other than it just sitting there. Now what we're going to be doing is we're going to be setting up some type of item collection. So when it's time for the player to use this object, it will start flashing. And it will only start flashing if the player is in the area. And then once the player collects the item, it will stop all the code altogether so that the level will be more optimized and use less code. So let's take a look at how we set this up. Again, first put your interp actor into the level with your texture on it. Now, in order for this to flash, we're actually going to need separate textures. So the first texture that you have on the object, on the static mesh itself inside the content browser, is going to be just the normal non-flashing texture. And then once the player gets close enough to it, then it's going to swap textures and be a flashing texture. So you'll need two different textures as seen here. You'll see in my content browser, I have my key object and I have two separate materials. Now, once it's in your content browser with two materials and it's in your level as an interp actor with the main material on it, you'll need to open up Kismet. And you'll see in this video here that there's going to be 4 separate sections of Kismet that we need to make this work. And this is not to just make it flash. This is to make it flash. This is so the player can collect it. This is so the computer knows that we've collected it. This is going to do checks and balances to make sure we've collected it and to make sure we're in the area so we can collect it and so it starts flashing, and to optimize the code so that it stops flashing, stops rendering, stops doing anything that it needs to do. So first up, let's take a look and see how we can actually set up this material. So in this picture here, you'll see that I have the same exact setup as the key that's in your content browser, but I've added some code that tells you where the texture is, where the color is, how it flashes over time, all of these things. So we're actually going to take a walk through this step by step and see how you use a scalar property or scalar parameter, time parameter, sine waves, multiply, vector properties, and all these things to get it to blend together. So first up, you have to create your texture and connect it to the diffuse. In this example, I just created a gray color because I don't have a texture that I actually want for this model. If you want to know how to make a color like I did using 3 RGB colors, you can just type in constant in the search bar to the right of your material browser. I'm using a constant 3 for 3 colors, R, G, and B. A constant 1 would have 1, which is red. Constant 2 would have R and G, red and green, and then the blue is for the third one. Up next, I've created a vector parameter. Again, you can type it in the right and it'll pop up. The vector parameter is basically just picking a specific color so that you don't have to type in the numbers like we did for the texture. And you also have a red, green, blue, and alpha channel, so you can divide those colors up however you like. Just to show you how it's working, I've connected the vector parameter in yellow to the emissive channel. And you can see that the emissive channel already has a basic glow or basic highlight to the texture. And it doesn't flash or anything like that, it just sits there. And when you have emissive turned on and you use light mask, the emissive actually does glow and calculate as light. So up next, I've disconnected the vector parameter and I've created a Fresnel. And you'll see that the Fresnel is brighter on one side of the cube and darker on the other. Fresnel is basically just how a color fades, okay? Up next, I have multiplied those two together. So I've taken the yellow and I'm fading it. You can see how part of the cube is yellow and the other part is gray. In the next one, I've done a scalar parameter. You'll notice that the scalar parameter is just a random number, and I typed in, well, it's not random, it's just a number, sorry. And I typed in 1 to make it white, and it just made the emissive glow a little bit more, but in a different way, okay? Up next, for the emissive, I've connected the time parameter. You'll notice the time parameter glows and has a glow around it. Now, just like the word itself says, time, this is something that will happen over time. However, this still does not animate either. It's still just a solid glow. So what I've done is I've connected the time and the parameter together, multiplying them together again. This might or might not glow. Basically, I can't remember at the moment. But it should glow. If not, it'll just sit there. Either way, the next step will make it glow or make it flicker. So up next, we have the sine wave. You'll probably remember from like your 8th or 9th grade class of math in high school to where sine wave goes up and down constantly, just like a cosine and tangent and all those other things. Well, the sine wave is going to make it go black to white based on the scalar parameter and the time. So the sine wave makes it turn on and off. In this picture, you'll see the cube is actually black. The time is going to be how fast over time it goes from black to white, back and forth, okay? Now, the sine wave is very on-off, like a light switch. It doesn't really fade. So what we're going to do is we're going to connect that fade to a constant 1. I just made it white. We just added those together. So instead of white and black, it's more shades of gray. So what you could consider that is a subtle blend on and off. So then in theory, if we connect that to the Fresnel, it'll not only be a subtle blend on and off, but it'll also be a smooth blend with the color. So what we're doing is we're setting the parameters on the Fresnel to make it a smooth blend, and then the sine wave to turn it on and off. So what we're going to do is we're going to then connect the sine wave, the add, and everything else to the Fresnel with a multiply and make those the emissive. And in the end, you'll see that we have this final glowing object just like the UDK has. Again, that is not the material that is on the object currently. That is just the material we're going to set it to. So in Kismet, what we need to do is set up the object so that we can collect it and turn the code on and off. So first up, we'll need to create a variable. This is going to be a true-false Boolean variable. So we're going to right-click and go to New Variable, Boolean, and we're going to create a false variable. In the properties, we're going to name it collected, because have you collected, yes or no, true or false? And obviously, if it's in the level, we have not connected it, or collected it. After that, we're going to select the item in our editor, and we're going to create a touch event, so that when we touch the object, we can make it disappear. Now keep in mind, as the static mesh in your content browser, it needs to have collision added to it. You should know how to do that. In your editor, once it's in your level, it should have a touch all collision added to it in the properties by hitting F4 and going to the collision dropdown. So when we touch this object, we want to destroy it. We want to make sure it is no longer in the level at all, which will actually speed up processing a little bit because it no longer has polygons, flashing, textures, materials, all these things. So we're going to right-click, New Action. I believe it's under Miscellaneous and Destroy. It might be under New Action Actor Destroy. So we're going to use that interp actor that we're going to collect as the target. And then since we've technically collected it by touching it and destroying it, we're going to create a bool, and we're going to set the value of that collected bool to true. Now you'll notice the target object on my bool has a little checkbox. That's because I'm using a named variable. So if you right-click, Variable, Named Variable, what you do is in the properties of that, you type in the name of the variable you want to reference. In this case, I'm referencing the collected variable that we set to false in the beginning. But now, since I collected it, I'm setting it to true. Then you'll notice we have a toggle that we're turning off an event. What we're going to be doing is turning off all the code that goes with it. So for now you can disregard that, but if you want to go ahead and set that up, you can. We're going to be turning off the code that is the event that is checking for the distance. So secondly, what we're doing is we're going to add a trigger volume around the key. What this trigger volume is going to do is it's going to tell the game, yes, the player is in the area. So let's start or turn on the flashing item. Let's turn on the area's code. So for example, let's say the player is outside the house, but inside a house is where specific things are going to happen. So you could have a trigger volume around the house that says, if the player is not in this area, don't do this code. But once the player is in the area, let's do this code. And that's what we're doing. We set up a trigger volume in the area where this item is going to be that we want to collect. Once we're inside that area, then the flashing will start. Then the code will start. So on this trigger volume, we're going to select it and create a touch event so that when the player touches it, it does the code. Now, first we're going to set a delay, which you can find under New Action, Miscellaneous Delay, or you could just right-click on that black box next to touched and set an active delay. It's up to you. 0.2 of a second to however long you want is up to you, but it has to be more than 0 or it could mess things up. Now, I'll show you a picture here. You'll notice in this picture there's a lot of error message popping up on the screen in game. That's because we do not have the delay working at that time. What's happening is you're running the loop so fast that the computer actually bogs down and freezes. So it creates a lot of issues. So by adding that delay in, it's slowing the computer down and letting us do what we need to do. So after we've started the delay, we're going to finish it. And when it's finished, we want to compare it, the bool. Okay, so what a bool is a true-false variable. So the bool that we're doing is the collected one that you'll remember from above or before, where that is whether or not we've collected the item. So when you go into this area where the trigger volume is, the computer is going to ask itself, is it true or false? Did the player collect the item or did the player not collect the item? So if the player did collect the item, you'll see that we have a log that's projecting to the screen that says true or yes, you've collected the item, and then it finishes the sequence. Nothing happens. If you are doing some kind of item counter to where if you collect a certain number of these things that something happens, then the finished sequence is where you would put your other kismet code. The log you actually don't need. We're just doing that for debugging purposes, just so you can see whether or not it's true or false that you've collected it. Now, so if the bool is set to false, then you can see the compare false will redo the delay. So it's going to wait half a second and then see if you've collected it. Wait half a second, see if you've collected it. Wait half a second, see if you've collected it. And that's only if you're inside that area where that volume is. However, if you have collected it, that bool will be set to true, and then it says, oh, you have collected it. True. Yes, you did. Let's do some other code. Let's finish that sequence. So let's say that you have not collected it, that it's false. That will then take us to another section of code, our fourth and final section. So if it's false, just for debugging purposes, we're going to have that log pop up on the screen that says false or no, you have not collected it. So if the item has not been collected, that means the player is in the area and might see the object and might want to collect it. So we're going to have to make it glow. And then if the player is not in the area, we're going to have to turn it off. That way the processing in the game can last a little bit longer or run a little bit faster and smoother. So you'll see we have a trace set up. The trace is going to start at that interp object. So you're going to select the object and then create a little node for the start. So the trace is going to run from the from the key item to the player. The player is our end variable. Now this could be any objects you want, but in this specific case, we know that the player needs to collect that item, so we're going to run a trace between those two things. Now what a trace is it's basically an invisible line drawn from the player to the object. Now if we were needing a hit object or some object in between the player and the item, we could use that, but since we automatically know we want the player to be the object, we can disregard it. Now what's going to happen is every time that trace is run, it has a number, a distance that's between the object and the player. And that distance gets saved in that blue distance arrow there. And you'll notice where it says key, player 1, and the distance, those are variable names that I've given them in the properties of each object, so that I could use a named variable down below where all those green check marks are. It's just to make it cleaner and easier to read. You could just drag lines to all those objects if you wanted to. And then obstructed means, did the end hit something? When it runs the trace from start to end, did it find what it was looking for? So in this case, it's always going to find the player. So it's always going to be obstructed. That line from the object is always going to hit the player because the player is always in the level, unless they die. So for 1 second, we might have to fix that as well, but we're not worried about that for now. So you'll notice in the bottom left there, it says if it's obstructed, we want to log the distance to the player. Okay, so the target is the player, and what a log does is it projects text on the screen. So basically we're just spitting out that number of distance onto the screen. And again, this is just for debugging. What's happening is when you're in that area of that volume, it's going to tell you how far away you are from the object. It's just something good to know as you're debugging, right? So if you're 700 Unreal units, if you're 200 Unreal units, if you're 1 Unreal unit away, and what we're going to do is we're going to set the glow to only flicker when we're within 200 Unreal units away. That's the code to the right. So you can see it's good for debugging. If I know that I'm at 205 and it's flickering, we have an issue. If I'm at 195 and it's not flickering, we have an issue. Right? So it all depends. We have to debug and test. We want to problem solve until our code is flawless. So on the right, again, if it's obstructed, we're going to check. We're going to compare the floats. We're going to compare the float value of the distance to a float value that I have set as 200. That's a number that I can change anytime I want. I'm just using it as an example to say when the player is 200 units from the object. Okay? So we're going to do a trace, then we're going to compare the distance from the player to the object, and if it is greater than 200, meaning I'm further away, I'm going to keep the same texture that's on it, the same material. But if I'm less than 200, I'm going to swap the material to the material that glows. So again, if I'm inside this trigger volume area, I'm going to constantly check to see if I'm close enough to it to make the texture glow. If I'm not, it's not going to make it glow. And then if I'm outside of the trigger volume, none of this code is going to work at all. So the computer will process things a little bit faster. So how do we make this trace happen constantly? Again, we have to go back to that delay on the trigger volume. If you remember, every time it's false, every time it says, did you collect this item? And we say, no, we have not collected it. It goes back to that delay, waits another half a second, and then asks the question again. So that can be considered a for loop, okay, or an if-then statement, depending on how you set it up. You'll also remember that we turned off an event. How did we do that? Well, again, once we touched the item, we destroyed it, we set the variable to true, and then we turn off the event that keeps asking that question. So if you're no longer asking the question of did you collect the item, then you're no longer wondering about it, you're no longer caring about it, and you're no longer processing that information. So in this video coming up here, you'll see that I'm standing outside of the trigger volume area and nothing is happening. Once I go inside the trigger volume, it starts giving me all the debugging information. It shows me my distance and whatnot. The material also swaps out and starts flashing when I get less than 200 units away. Then when I collect it, it says true, yes, you collected it, and then all the code stops. And then if I go inside or outside of the volume, nothing happens anymore because I've already collected the item. So this is a quick walkthrough showing you how to set up the glowing material and how to set up the kismet, and have fun.